Look at the second problem on these examples here, and I'll move to the document camera to work through the second equation. So if you didn't get this right, we can try and find where that mistake was made. So for this one, I want to use the elimination method, or you were asked to use the elimination method or the addition method. So if we add straight down the line here, if we combine the x's, combine the y's, we want one of these variables to eliminate, to add to 0. So 5 plus 3 is not 0. 2 plus 7 is not 0. So as it sits right now, it does not work for the elimination method. So we have to manipulate the situation. Now the last one, we had -5 and -5 to start with, and so the 5's already matched, which means that we just had to make one positive and it worked. In this example, none of the numbers match. So not only do we need one of them to be positive and one of them to be negative, we also need them to be the same number. And it doesn't matter if we do the x's or the y's. In fact, for this one, I'll do the y's. So I want the y's to eliminate. That's going to be my goal here. I want the 2 and the 7 to be the same number, same coefficient for y. I also want one to be a minus and one to be a plus. So that's the goal. I want to try and find the least common multiple between these two, but the easiest way to get a common multiple is to multiply them together. So if I multiply, I'm going to say the numerator, but really the first equation here times 7. So again, I want these two to match. So I'm going to multiply the first equation by the coefficient here, 7. And I'm going to multiply the second equation by this coefficient here, the first coefficient, 2. So I want the y's to eliminate because I'm choosing y. You could choose x, but I'm going to choose y. So I'm going to multiply the first equation by 7, second equation by 2. And one of them has to be negative. So I got a plus and a plus. I need one of them to be a minus. That way, they'll add to 0. So if I multiply through, I'd have 35x plus 14y equals -7. And I'll have -6x minus 14y. So that's good. Positive 14, -14, that's going to become 0 when I combine those together. And I'm going to get -22. So don't forget to multiply through to everything in both equations. Now if I combine like terms, 35x plus -6x is going to give me what, 19? No, sorry. 29x, 0y, and that's going to give me -29. Well, I can see just by looking at it that x would have to be -1. 29 times -1 would give me -29. However, I could always divide both sides by 29 to show that that is in fact the solution. So x is -1. We've got x halfway there. Now we need to figure out y. It doesn't really matter what equation I need to use. I've got 4 different equations that all work at the exact same time when x is -1. I'll choose, I don't know, I guess I'll choose the first one. So I'm using this original equation here. I know what x is now. X is -1. So I'm going to substitute that in. -5 plus 2y equals -1. If I add 5 to both sides, I get that 2y equals 4, which means that y is going to have to be 2. So I've solved for x. I use that x to solve for y. And my final answer, x is -1 and y is 2. Now, I'm drawing those little arrows there to point to it. You certainly don't have to. The only reason I'm drawing those arrows is because I boxed 2 other things as well. This is my final answer, -1, 2. And that's how we get those solutions.